In question 1, we are asked to find this integral, writing each term in its simplest form. So the first thing to do is expand the numerator. We've got the integral of 2x to the 3 over 2 minus 5x to the half, and all of it over 3 with respect to x. And the next obvious step is to write this in an index form. So we've got 2 over 3 x to the 3 over 2 minus 5 over 3 x to the half dx. So we know that in integration we increase the power by 1 and we divide by the new power. So it's 2/3, and we've got x to the 5 over 2 divided by 5 over 2 minus 5 over 3. We've got x to the 3 over 2 divided by 3 over 2. And we also have the constant of integration, so plus c. Now this simplifies to 4 over 15 x to the 5 over 2 minus 10 over 9 x to the 3 over 2 plus c. In question 2 here, we've got f of x defined in terms of a positive constant a. We are additionally told that x minus a is a factor of f of x, and we need to show that a brackets 4a squared plus 5a minus 6 is equal to 0. Well, we know that if x minus a is a factor, then f of a is 0. So I will be substituting x with a, so we get 4a cubed plus 5a squared minus 10a plus 4a is equal to 0. Now this leads to 4a cubed plus 5a squared minus 6a is equal to 0. I will factor out the a to get a brackets 4a squared plus 5a minus 6 close bracket is 0 as required. And in part B, we need to find the value of a and then use algebra to find the exact solutions of the equation f of x is 3. Now to find the value of a, I will proceed by factorizing the full expression we obtained here. So it's a bracket, and then we've got 4a minus 3, a plus 2, and all of this is equal to 0. This means that either a is 0 or 4a minus 3 is equal to 0, or a plus 2 is equal to 0. Now the value of a being 0 is rejected. It's not valid because we have been told that the a is a positive constant. If 4a minus 3 is 0, that means that 4a is equal to 3, and therefore a is 3 over 4. And if a plus 2 is 0, then a is negative 2, which is also rejected for exactly the same reason. A being a positive constant means that a cannot be negative 2, and therefore we conclude that since a is positive, a must be 3 over 4. Now to solve f of x is equal to 3, let me start by writing out that f of x is now 4x cubed plus 5x squared minus 10x plus 4 times the value of a, which we found to be 3 over 4, and this is equal to 3. Now this leads to 4x cubed plus 5x squared minus 10x plus 3 is equal to 3. Now obviously the 3 with the 3 will cancel out, and I will factor out the x. So we've got x brackets 4x squared plus 5x minus 10 is equal to 0. So either x is 0 or the 4x squared plus 5x minus 10 is 0. Now this will be solved using the quadratic formula. So we get that x is minus b plus minus b squared minus 4ac square root and all of it over the 2a, which in our case is 2 times 4. And this leads to minus 5 plus minus root of 185 and all of it over 8. So we've got a total of 3 solutions: the 0, the positive, and the negative. In question 3, we're given the position vector of point A and point B. A is known to be a positive integer, and we need to show that the magnitude of the vector OA is root of 38. Well, we know that to find the magnitude of a 3D vector, I will simply take each component, square it, and take the square root. So it's going to be 5 squared plus 3 squared plus 2 squared and all square root, which gives an answer of root 38 as required. In part B, we need to find the smallest value of A, for which the magnitude of OB is greater than the magnitude of OA. So it certainly makes sense to start off by finding the magnitude of OB, which is equal to 2 squared plus 4 squared plus a squared and all square root. This gives an answer of the square root of 20 plus a squared, and we have that the magnitude of OB is greater than the magnitude of OA. So the left hand side of this inequality is simply the square root of 20 plus a squared, and the right hand side is simply the square root of 38 we found in part A. Now I will remove the square roots by squaring both sides, which leads to 20 plus a squared is greater than 38, and therefore a squared is greater than 18. Well, we have been told that a is a positive integer, and we know that 4 squared is equal to 16, while 5 squared is equal to 25. We see that the first integer that upon squaring exceeds 18 is 5, which leads to the conclusion that a is equal to 5. In question 4, we've got a curve C with equation y is f of x, giving the first derivative to be 2x plus a half cos x. We know we have a stationary point with x coordinate being alpha, and alpha is small, and we need to use a small angle approximation for cos x to estimate the value of alpha correct to 3 decimal places. Well, let's start by reminding ourselves that if theta is small and in radians, then cos of theta may be approximated by 1 minus theta squared over 2. This is given in the formula booklet. And we know that for us to have a stationary point at x is alpha, this means that f dash of alpha, which is 2 alpha plus a half cos of alpha, this must be equal to 0 for this point to be a stationary point. Now using the small angle approximation, I get 2 alpha plus a half of 1 minus alpha squared over 2 is equal to 0, which gives me 2 alpha plus a half minus alpha squared over 4 is equal to 0. I will multiply throughout by 4 to get 8 alpha plus 2 minus alpha squared is equal to 0. And I will be collecting everything on the right hand side to get 0 is equal to alpha squared minus 8 alpha minus 2. And I can use the quadratic formula here to determine the values for alpha. So alpha is negative minus 8 plus minus the b squared, so the negative 8 squared minus 4ac and all square root and all divided by 2a, which is 2 times 1. So we get alpha to be 8.243, or the alternative solution is alpha being negative 0.243. Well, we know that for the small angle approximation to hold true, apart from theta being in radians, it must be the case that theta is small and 8.243 is not considered to be small. So I have to say that I reject the 8.243. It's not valid. So the value of alpha is negative 0.243, correct to 3 decimal places. In part B, we're given the point P03 lying on C, and we need to determine the equation of the tangent to the curve at P, giving our answer in the form y cos mx plus C. Well, I will start by evaluating f dash of 0, which is the gradient of the tangent at the particular point. So it's going to be 2 times 0 plus a half cos of 0, which gives an answer of a half. This is the gradient of the tangent. Now, this particular point lies on the y-axis, so it is the y-intercept of the tangent, and therefore we simply conclude that the equation of the tangent is y is a half x plus 3. In question 5, we've got a table of values for a continuous curve with the equation y is f of x. Now the trapezium rule being used with all the y values in the table gives an approximate area for the area enclosed between x is 3 and x is 4, and we are told that this value came out to be 17.59. We need to show that this leads to a plus 2b is 51. Well, if I apply the trapezium rule on this value, we know that this will be a half times the height of the trapezia, which is given by the difference of 2 consecutive values of x, which is 0.2. So any 2 consecutive values of x appear with a difference of 0.2. So a half times 0.2, and then it's the first and last y values once, and all intermediate values of y twice. So 2 times 16.8 plus b plus 20.2 plus 18.7, and all of this is giving an answer of 17.59. Well, the left hand side simplifies to 0.1 brackets a plus 13.5 plus 2 times the 55.7 plus b close brackets, which is equal to 17.59. Well, I will divide both sides by 0.1 and I get A plus 13.5 plus 111.4 plus 2B is equal to 175.9, and therefore we get that A plus 2B plus 124.9 is equal to 175.9, and therefore we obtain that A plus 2B is equal to 51 as required. Given also that the sum of all the y values in the table is 97.2, we need to determine the value of A and the value of B. So essentially I need to produce another equation that involves A and B and proceed by solving simultaneously in A and B. So let me start by adding all the y values. So we've got A plus 16.8 plus B plus 20.2 plus 18.7 plus 13.5, and this is equal to 97.2. So we get that A plus B plus 69.2 is equal to 97.2, and therefore A plus B is equal to 28. Well, we have already established that A plus 2B is equal to 51. So if I deduct this from the second equation, we get that B is equal to 23, and I can proceed in finding A by substituting into A plus B is 28. So this leads to A plus 23 is equal to 28, and therefore A is equal to 5. In question 6, we have that A is log of x base 2 and B is log of x plus 8 base 2, and we need to express in terms of A and or B the log of root x base 2. So starting with what we're given, we've got log of root x base 2, which can be written as log of x to the half base 2. Now through the power law of logarithm, the half can come down, so it's a half log of x base 2, which is obviously a half A. In part B, we've got log of x squared plus 8x base 2 to be expressed in terms of A and B. So the first thing to do is factorize. So we've got log of x brackets x plus 8 base 2. Now through the product rule of logarithms, this can be written as log of x base 2 plus log of x plus 8 base 2. And this is obviously A plus B. And finally, in part C, we are dealing with the logarithm of 8 plus 64 over x and all of it base 2. The first thing we could do is express this as a single fraction, so it's log of 8x plus 64 and all of it over x base 2. So this can be written as the logarithm of 8x plus 64 base 2 minus the logarithm of x base 2. So I can factor out the a to get the log of 8 brackets x plus 8 base 2, and the logarithm of x base 2 is simply a. So this can be further split into the logarithm of 8 base 2 plus the logarithm of x plus 8 base 2 minus a. Well, log of 8 base 2 is 3 because 2 to the power of 3 is 8. Log of x plus 8 is b minus a, so the answer is 3 plus b minus a. In question 7, we've got the function f of x defined to be 3 plus the root of x minus 2, and it's defined for x being greater than 2, and we need to state the range of f. Well, we know that if we start from x being greater than 2, then x minus 2 is greater than 0, and if I take the square root of both sides, then the square root of x minus 2 is greater than the square root of 0, which is 0. I will then add 3, so 3 plus the square root of x minus 2 is certainly greater than 3. So all I'm trying to do here is reconstruct the expression for f of x. So we have just seen that f of x is greater than 3, and therefore we conclude that the range of f is y belongs to the real numbers and y is greater than 3. In part B, we are asked to find f inverse, and to do that I will start by writing y is equal to 3 plus the square root of x minus 2, the expression for f of x. I will then interchange x and y, so x is equal to 3 plus the square root of y minus 2, and we're now trying to make y the subject, so this means that we've got x minus 3 is equal to the square root of y minus 2. I will remove the square root by squaring both sides, so x minus 3 squared is equal to y minus 2, and therefore we get that x minus 3 squared plus 2 is equal to y. Now this means that f inverse of x is equal to x minus 3 squared plus 2, and also notice that we need to provide the domain for f inverse of x, and the domain of the inverse is the range of the original function, so we need to say that x belongs to the reals and x is greater than 3. Remember that the domain is expressed in terms of x, whereas the range is expressed in terms of y. In part C, we need to find g of f of 6, a composite function where g of x is defined to be 15 over x minus 3. So g of f of 6, I will first start with the inside. I will find f of 6 and then proceed with g. So this is going to be g of 3 plus the square root of 6 minus 2. Now 3 plus the square root of 6 minus 2 is simply 5. So we're looking at g of 5, which is 15 over 5 minus 3, which gives an answer of 15 over 2. In part D, we need to find the exact value of the constant a, for which f of a squared plus 2 is equal to g of a. So f of a squared plus 2 is simply 3 plus the square root of a squared plus 2 minus 2, and this is equal to g of a, which is 15 over a minus 3, where the 2 with the negative 2 cancel out, and 3 plus the square root of a squared is 3 plus a, and this is equal to 15 over a minus 3. So I will cross multiply to get 3 plus a times a minus 3 is equal to 15, and I will expand, getting 3a minus 9 plus a squared minus 3a is equal to 15. Now the 3a with the minus 3a cancel out, and I get that a squared is equal to 24, which means that a is plus minus the root of 24. Now the question is referring to the exact value of the constant a, so I can't have two solutions. It must be one of them correct and the other to be rejected. So in order to decide which one is to be rejected, I'll have to check against the original equation that was given here. So if we start with a being minus root 24, we see that f of a squared plus 2 is equal to f of negative root 24 squared plus 2, and this gives an answer of f of 26, which is equal to 3 plus the square root of 26 minus 2, which is 3 plus root 24, whereas the g of a is going to be g of negative root 24, which is 15 over the negative root 24 minus 3, which is equal to 3 minus root 24. Now we can see that these two are not equal, so a is negative 24 cannot be a valid answer for a, and therefore we conclude that a must be the square root of 24. In question 8, we've got the plan view of a stage shown here. The angle COE is 2.3 radians and the length of the arc CDE is 27.6 meters. And we need to show that OC is 12 meters. Well, we know that the length of the arc when theta, the angle is measured in radians, is given by r theta, which means that in our case we've got 27.6. The arc is equal to OC times 2.3. Well, if I divide 27.6 by 2.3, I get 12 to be OC, and therefore we conclude that OC is equal to 12 meters as required. In part B, we need to show that the size of the angle AOB is 0.421 radians correct to 3 decimal places. So AOB is the angle here. Well, we know that all of these 180 degrees or pi radians. So because the two triangles here are congruent, it means that the two angles are of the same size, and therefore AOB can be found by doing pi minus 2.3 divided by 2, which gives an answer of 0.420796 ... which rounds to 0.421 radians as required. We're then told that the total length of the front of the stage BCDEF is 35 meters, and we need to find the total area of the stage, giving our answer to the nearest square meter. Well, let's start with adding all the information we have found up to now. we have established that OC is 12 meters, the angle at BOA 0.421 radians. By symmetry, this means that the AO is half of 15, so it's 7.5 meters, and I will be splitting the areas into the sector and the two triangles which are congruent. I will then find the length of BC, and to find the length of BC, this part here, I will simply do 35 minus the length of the arc 27.6 and divided by 2, because the BC with the EF are exactly of the same length. This gives an answer of 3.7 meters, and therefore we have that the length OB is equal to 12 plus 3.7, which gives an answer of 15.7 meters. We will then proceed by reminding ourselves that the area of a sector is given by a half r squared theta when theta is measured in radians, and to find the total area I'll be doing 2 times the area of the triangle AOB. So we've got 2 times a half AB sine C, so a half times 7.5 times the 15.7 times the sine of the included angle, which is 0.420796 ... plus the area of the sector, which is a half r squared theta, and theta is 2.3. Plug this on the calculator, you get 213.699 ... which correct to the nearest square meter is 214 square meters. In question 9, we've got the first 3 terms of a geometric sequence given here in terms of k, and we need to show that this leads to the given quadratic equation. Well, we know that in a geometric sequence, the ratio of consecutive terms is the same. So u2 over u1 is equal to u3 over u2, which in our case means that 12 minus 3k over the 3k plus 4, the u2 over u1, is equal to k plus 16 over the 12 minus 3k, which is the u3 minus u2. I will proceed by cross multiplying to get 12 minus 3k times 12 minus 3k is equal to k plus 16 times the 3k plus 4. I will then expand the brackets to get 144 minus 36k minus 36k plus 9k squared is equal to 3k squared plus 4k plus 48k plus 64. I will simplify this into 144 minus 72k plus 9k squared on the left hand side, which is equal to 3k squared plus 52k plus 64 on the right hand side. Collecting all terms on the left hand side gives me 6k squared minus 124k plus 80 is equal to 0. And if I divide by 2 throughout, I get 3k squared minus 62k plus 40 is equal to 0 as required. Now, given that the sequence converges, we need to find the value of k, giving a reason for our answer and determine the sum to infinity. So, we've got the given quadratic here. I will start by factorizing this, which gives me 3k minus 2 being the first bracket, times the second bracket, which is k minus 20, and this is equal to 0. So we've got 3k minus 2 is 0, or k minus 20 is equal to 0, which means we've got 3k is 2, and therefore k is 2 over 3, or k is 20. Now these two are the two candidate values for k, but I still need to use the fact that the series is convergent in order to determine the appropriate value for k. And to do that, I'll be finding u1 and u2 for each value of k. So u1 is equal to 3k, so 3 times 2 over 3 plus 4, which gives a value of 6. And u2 is equal to 12 minus 3k, so 12 minus 3 times 2 over 3, which gives an answer of 10. And we see that r is u2 over u1, the ratio of the next term over the previous term, which is equal to 10 over 6. Whereas for k is 20, we get u1 is equal to 3 times 20 plus 4, which gives an answer of 64. And u2 is 12 minus 3 times the k of 20, which gives an answer of negative 48. Now this time r is equal to minus 48 over 64, which gives an answer of minus 3 over 4. Well, we know that the series, a geometric series, is convergent if the absolute value of the common ratio is less than 1. So if r is between -1 and 1, so 10 over 6 is greater than 1, minus 3 over 4 is greater than -1. And therefore we conclude that since the sequence converges, we need the absolute value of r to be less than 1, and therefore k must be 20. Now, to find the value of the sum to infinity, let's recall that the sum to infinity is given by a over 1 minus r, where a is the first term and r is the common ratio. Well, we have determined that k is 20, so the first term is 64, and the common ratio is minus 3 over 4. So let's state this: a is equal to 64, r is equal to minus 3 over 4, and therefore we have that the sum to infinity is equal to 64 over 1 minus the negative 3 over 4. Well, this gives an answer of 256 over 7, and we need the exact value of the sum to infinity. In question 10, we've got the circle C with the given equation here in terms of the constant k, and we need to find in terms of k the coordinates of the center and the radius of the circle. Well, let's start by reminding ourselves that the circle, which is centered at alpha beta having a radius of r, has equation x minus alpha squared plus y minus beta squared is r squared. So starting with what we were given, we had x squared plus 6kx plus y squared minus 2ky plus 7 is equal to 0. And I will be completing the square both for x and y. So this leads to x plus 3k all squared minus 3k all squared plus y minus k all squared minus k squared plus 7 is equal to 0. So we've got x plus 3k all squared minus 9k squared plus y minus k squared minus k squared plus 7 is equal to 0, which means we've got x plus 3k all squared plus y minus k all squared is equal to 10k squared minus 7, and we therefore conclude that the center of the given circle has coordinates negative 3k comma k, whereas the radius is simply the square root of the right hand side, so it's the square root of 10k squared minus 7. In part B, we've got the line with the equation y is 2x minus 1 intersecting C at two distinct points, and we need to find the range of possible values of k. Well, let's start with the equation of the circle we were given, and I will be substituting y is 2x minus 1. So I'm essentially solving simultaneous equations here. So this leads to x squared plus 2x minus 1 all squared plus 6kx minus 2k times the 2x minus 1 plus 7 is equal to 0. I will expand to get x squared plus 4x squared minus 4x plus 1 plus 6kx minus 4kx plus 2k plus 7 is equal to 0, which leads to 5x squared plus 2kx minus 4x plus 2k plus 8 is equal to 0. This means we have obtained a quadratic in x, which I will write as 5x squared plus brackets 2k minus 4x plus 2k plus 8 is equal to 0. And we know that for the line to intersect at two distinct points, this means that the discriminant is greater than 0. Well, the coefficient of x squared is 5, the coefficient of x is 2k minus 4, and the constant term is 2k plus 8. So the discriminant is b squared minus 4ac, which in our case is 2k minus 4 squared minus 4 times the 5 times the 2k plus 8, and this should be greater than 0. So we get 4k squared minus 16k plus 16 minus 20 times 2k plus 8 is greater than 0. I will further expand this to get 4k squared minus 16k plus 16 minus 40k minus 160 is greater than 0, which leads to 4k squared minus 56k minus 144 is greater than 0. I will divide throughout by 4 to get k squared minus 14k minus 36 is greater than 0. And I can proceed in finding the critical values. Well, to find the critical values, I'll be using the quadratic formula. So we've got k is minus the negative 14 plus minus the b squared, so negative 14 squared minus 4ac and all square root and all divided by 2a, so 2 times 1. This gives critical values of k being 7 plus minus root of 85, which I can plot on my parabola. We can see we go plus, minus, plus. We want to be greater than 0. We want to be positive, so we want the outside region. And therefore, we conclude that k is less than 7 minus root 85, or k is greater than 7 plus root of 85. Now, strictly speaking, we've got more restrictions on k, so if we briefly go back to the radius here we obtained, we had 10k squared minus 7, the square root of this is the radius, so the values of k should satisfy that the argument within the square root is always a non-negative. So we could also observe, we could say that also 10k squared minus 7 needs to be greater than 0 for this to be indeed a circle, because I will be taking the square root of a positive number for the radius. This means that 10k squared is greater than 7, so k squared is greater than 7 over 10. So this is a second quadratic inequality. Critical values can easily be found by taking the plus minus square root of 7 over 10. So we've got k is plus minus the square root of 7 over 10. And once more, I will plot this on the parabola. Here are my critical values. I still go plus, minus, plus. We want to be greater than 0 once more. So we want to be on the left or right hand tail. So this means that k is less than minus the root of 7 over 10, or k is greater than the square root of 7 over 10. And if I plot everything on the same number line for k, we can see that we want the k to be greater than the 7 plus root 85 or less than the 7 minus root 85. We want k to be greater than the square root of 7 over 10 or less than the negative square root of 7 over 10. So we see that all of this is satisfied for k being less than the 7 minus the root of 85, or for k being greater than the 7 plus the root of 85. Well, the extra conditions we derived here did not play any role, but still we had to check to make sure that everything is satisfied for k. In question 11, we've got the value capital V pounds of a mobile phone T months after being bought, and its model through V is AB to the T. We can see that plotting log V base 10 against T leads to a straight line passing through these 2 points. We need to use these points to find the initial value of the phone. Well, looking at the cut on the vertical axis, we can see that when T is 0, the log of V is 3. So when T is 0, log of V base 10 is equal to 3. And therefore V is 10 to the 3, which is 1,000 pounds. In part B, we need to find a complete equation for V in terms of T, giving the exact value of A and giving the value of B to 3 significant figures. Well, I will start by finding the gradient of the given straight line. So it's going to be 2.79 minus 3 over the 10 minus 0. So I'm doing rise over run here. This leads to minus 0.021. We can also see that the y-intercept is 3, so C is 3. So we've got that log of V base 10, which is the y, essentially, is equal to 3 minus the 0.021 t. This is the equation of the straight line. Well, at the same time, we have been given that V is AB to the t, and I will take logs to match the form of this expression here. So taking logs of both sides leads to log of V base 10 is equal to log of AB to the t base 10. Well, I will be splitting the right hand side using the product rule of logarithms, which says that log of A base 10 plus log of B to the t base 10. So this means that log of V base 10 is equal to log of A base 10 plus t log B base 10. Now, if we compare this with this here, we can see that the 3 is the log A base 10, whereas the negative 0.021 is the log of b base 10, which means that log of a base 10 will be set equal to 3, and therefore a is 10 to the 3, which is 1000. It's the initial value of the phone, and the log of b base 10 is negative 0.021, which means that b is 10 to the negative 0.021, which gives an answer of 0.953. Well, remember we had to find a complete equation for v in terms of t, so I still need to write down the complete equation. So v is 1000 times the 0.953 raised to the power of t. Now, exactly 2 years after being bought, the value of this phone was £320, and we need to use this information to evaluate the reliability of the model. Now, remember that the variable t is the number of months after the phone was bought. So 2 years simply means that t is 24. So when t is equal to 24, we get v is 1000 times the 0.953 to the power of 24. This gives an answer of 315. Now notice that if you use the exact value you obtained for b, not the rounded to 3SF value, but the exact value, the 10 to the minus 0.021, you will get here not 315 but 313. In any case, the 315 is close to 320, and therefore we can easily conclude that the model is reliable. In question 12, we've got y sine x with x being in radians, and we need to use differentiation from first principles to prove that the derivative is cos x, and we will be using the formula for sine of a plus b, so the addition formula for sine, as well as the fact that as h tends to 0, sine of h over h tends to 1, and cos h minus 1 over h tends to 0. Well, let's start with the basics. We know from the formula booklet that the derivative f dash of x is defined to be the limit as h tends to 0 of f of x plus h minus f of x over h. And in our case, f of x is sine x. So the next step is to find f of x plus h, which is going to be sine of x plus h. I will now use the addition formula for sine a plus b. So this is sine of x cos of h plus cos x sine of h. Now, using the formula for the derivative, I will be substituting. So we've got that f dash of x will be the limit as h tends to 0 of sine x cos of h plus cos x sine h minus sine x, and all of it over h. And I will then be grouping together the sine x terms. So this is the limit as h tends to 0 of sine x, and we've got in brackets cos of h minus 1 over h plus cos x times sine of h over h. Well, we have seen that the cos of h minus 1 over h tends to 0 as instructed by the question itself, whereas sine of h over h tends to 1. So we can see that the first term here will be 0, whereas the second term will simply be cos x, leading to f dash of x being cos x as required. Question 13, we've got a roller coaster ride with passengers traveling in carriages around a track. Now the circuit is such that the maximum vertical height is 60 meters and the carriage starts at a vertical height of 2 meters above ground. The ground is horizontal. We are given a model here for the vertical height, capital H meters above ground, t seconds after we start the first circuit, and we need to find a complete equation for the model. Well, let's start with the obvious thing. This is put in a particular form that allows the maximum height to be determined easily. It's when this is 0. So we can see that the maximum height is when t is 20, and if t is 20, then this simply means that h is a, and therefore we conclude that since the maximum vertical height was given to be 60 meters, this simply means that a is 60. Now I will then use the second piece of information, so that originally we were at a height of 2 meters. This simply means that when t is 0, capital H is 2. So I will be substituting to get 2 is equal to a, which was found to be 60, minus b times 0 minus 20 all squared. This leads to 2 is equal to 60 minus 400b, and therefore 400b is equal to 58, which means that b turns out to be 29 over 200. Remember, we need to find a complete equation for the model, which means that we've got that h is equal to 60 minus 29 over 200 times t minus 20 all to the power of 2. In part B, we need to use the model to determine the height of the carriage above ground when t is 40. So this simply calls for us to substitute t is 40 into the equation we just obtained. So h is 60 minus 29 over the 200 times the 40 minus 20 all squared. This gives an answer of 2 meters. Remember to include the units. Now in an alternative model, the vertical height capital H meter is given by 29 cos of 9t plus alpha plus beta, with alpha and beta being constants, and we need to find a complete equation for this alternative model. Well, we can see that the cos of 9t plus alpha varies between plus minus 1, and therefore the 29 cos will vary between plus minus 29. So it's easy to determine that the maximum height will simply be given by 29 plus beta, and we know that this maximum height is 60, which simply means that beta turns out to be 31. And then I can proceed with the fact that originally the height was 2 meters, so when t0h is 2, so this means that 2 is 29 cos of 9 times 0 plus alpha plus the beta, which was found to be 31. So we get minus 29 is 29 cos of alpha. So minus 1 is cos alpha. So alpha is simply shift cos of negative 1. And we get that alpha is equal to 180. We still need to write the complete equation. So we've got that h is 29 cos of 9t plus 180 plus the 31. Now, given that the carriage moves continuously for 2 minutes, we need to give a reason why the alternative model will be more appropriate. So I will start by substituting t is 120. Remember that t, the time, was measured in seconds. So 2 minutes that we are given here is 120 seconds. So according to the first model, h is given by 60 minus 29 over 200, and then we've got the 120 minus 20 all squared. This gives an answer of minus 1390, which is less than 0, which is obviously not valid because the height cannot attain negative values. Whereas with the alternative model, if I do the same process, we've got that h is 29 cos of 9 times 120 plus 180 close brackets plus 31. This gives an answer of 2, which is positive, which is valid. And we therefore conclude that the alternative model is more appropriate. Alternatively, someone could say that under the alternative model, we allow for repetition or more than one circuit, which reflects the true situation here, whereas the first model, the parabola, does not allow for this. In question 14, we are asked to prove using algebra that n plus 1 all cubed minus n cubed is odd for all n in the natural numbers. Remember, the natural numbers are the positive integers, and we need to construct a solid proof here to prove the given result. So I could start by considering exactly the n plus 1 cubed minus n cubed, and upon expanding I get n cubed plus 3n squared plus 3n plus 1 minus n cubed. Obviously, the n cubed with the n cubed cancels out, and I can write this as 3n times n plus 1 plus 1. So essentially, I group the 3n squared and the 3n together, and I factor out the 3n. And we notice now that the n times n plus 1, since n is a natural number, a positive integer, it's simply the product of two consecutive integers. Hence, one of them is surely even and the other is surely odd. Now, if I multiply an even by an odd, I get an even result. And if I add 1, I will end up with an odd result, which means I can write a conclusion. Hence, 3n times n plus 1 is 1 more than an even number. Therefore, it's odd, which leads to the overall conclusion that n plus 1 cubed minus n cubed is odd for all n in the natural numbers. Remember, we're constructing a proof here, so we need to end up with the conclusion, which is exactly what we had to show. In question 15, we've got f of x here, and we need to show that the first derivative can be put in this form with a and b being constants to be found. Now, this is indeed a challenging question because we've got to differentiate, and we've got the product rule in the numerator, but also the quotient rule because we are dealing with a quotient. So f of x is 7x e to the x over e to the 3x minus 2 raised to the power over half. So to find the derivative, I will start by differentiating the top, the derivative of 7x e to the x. Well, this is where I apply the product rule. I've got the product of 7x and e to the x. So the derivative of 7x is 7, and I keep the e to the x plus 7x times the derivative of e to the x, which is e to the x. And I keep the bottom, which is e to the 3x minus 2 raised to the power of a half, minus I keep the top of 7x e to the x, and I differentiate the bottom, so I get the power down. I deduct 1 from the power, so it's e to the 3x minus 2 raised to the minus a half times the derivative of the bracket. Well, the derivative of e to the 3x minus 2 is simply 3e to the 3x, and this will be all over the original denominator square, so over e to the 3x minus 2. I then notice that 7e to the x is a common factor that appears here and also here, so I will take it out. So I can also see that it appears in the answer I need to arrive at. So I've got 7e to the x, and then in brackets I've got 1 plus x times e to the 3x minus 2 raised to the power of a half minus 3x over 2 times e to the 3x times e to the 3x minus 2 raised to the minus a half, and all of it over the e to the 3x minus 2. I look at what I have here and I'm trying to match it essentially. So I can see there is a 2 in the denominator, so it makes sense to multiply everything by 2. So this leads to 7e to the x, and I've got in the bracket 2 plus 2x times e to the 3x minus 2 raised to the power of a half minus 3x e to the 3x e to the 3x minus 2 to the minus a half, and all of it over 2 times e to the 3x minus 2. Now looking at the answer once more, we can see that there is no e to the 3x minus 2 bracket in the numerator, so I will multiply top and bottom by e to the 3x minus 2 to the half. This leads to 7e to the x, and I've got 2 plus 2x times e to the 3x minus 2 minus 3x e to the 3x, and in the denominator I'll be having 2 times e to the 3x minus 2 and raised to the power of 3 over 2. Remember, we have multiplied top and bottom by e to the 3x minus 2 raised to the power of a half. I will then expand the brackets in the numerator, so 7e to the x, and I've got 2e to the 3x minus 4 plus 2x e to the 3x minus 4x minus 3x e to the 3x, and in the denominator I've got the 2 brackets e to the 3x minus 2 raised to the power of 3 over 2. I will be collecting like terms within the numerator, so this leads to 7e to the x, and we've got 2e to the 3x minus x e to the 3x minus 4 minus 4x close brackets over the 2 brackets e to the 3x minus 2 raised to the power of 3 over 2, which can be put in the form of 7e to the x, and we've got in brackets the 2 minus x e to the 3x, so I factor out the common factor of e to the 3x minus 4x minus 4, close the big brackets, over 2 times e to the 3x minus 2 raised to the 3 over 2, which matches exactly the form in which we needed to arrive at here. And we can see that a, the constant a, has the value of -4, and the constant b also has the value of -4. In part B, we need to show that the x-coordinates of the turning points are solutions to this equation here. So let's start with the fact that the turning point means that we've got f dash of x is 0. This is what we obtain for f dash of x. We set this equal to 0, and we can see that either e to the x is equal to 0, or we've got that e to the 3x times 2 minus x minus 4x minus 4 is equal to 0. Now, if e to the x is 0, obviously we've got no real solution, so we say reject. This is not valid, and we are hoping to get the equation shown here from this equation we just obtained. So I will start by expanding. We've got 2e to the 3x minus x e to the 3x minus 4x minus 4 is equal to 0. Now this means I can write 2e to the 3x minus 4 is equal to x e to the 3x plus 4x, and we can then proceed by factoring out the x from the right hand side. So 2e to the 3x minus 4 is equal to x brackets e to the 3x plus 4, which means that 2e to the 3x minus 4 over the e to the 3x plus 4 is equal to x as required. We are then told that the student uses the given iteration formula to find approximations for alpha and beta, with alpha and beta being the two positive roots of this equation here. Now we need to draw a staircase diagram here to show that starting with x1 is 1, we will eventually arrive at beta. So starting at 1, I draw my staircase diagram, so I keep rising towards the right, and I draw several lines to show that I'm tending towards beta, which means I can safely conclude that starting with x1 is 1 can be used to find an approximation for beta. In part D, we are asked to start at x1 is 1 to find to 3 decimal places the value of x2 and the value of beta. So I'm gonna go on my calculator, I press 1, and I store it on my answer key, and then I'm going to be using the iteration formula, which has in the numerator 2e to the 3 uns, which at the moment holds the number 1 minus 4 over the e to the 3 uns, and we've got a plus 4 as well. So each time I press the equal sign, we've got a new iteration here. So I press the equal sign once, and this gives me an answer of 1.501775. So let me write the full accuracy here. So x2 is 1.501775 ... Remember, we need to give our answers to 3dp, so this is 1.502. And to find the value of beta, which is the true value, the true root, I will keep pressing the equal sign. We can see that the numbers change and eventually stabilize at 1.96757 ... So to 3dp's, we can safely conclude that beta is 1.968. Finally, in E, we need to use a suitable interval and a suitable function that should be stated to show that alpha is 0.432 to 3 decimal places. Alpha is the other root. So starting with alpha being 0.432 correct to 3dp's means I'm looking for a change of sign between 0.4325 and 0.4315. Well, I'm always looking for a change of sign on what needs to be 0, and in this case it's a turning point, so the first derivative is 0, so I will be substituting to f dash, so 0.4325, which gives an answer of 0.0183, and 0.4315, which gives an answer of minus 0.005789. Well, we have seen the change of sign we were after. We also need to mention that f dash of x is continuous, and therefore we've got a root existing between 0.4315 and 0.4325. So whatever the true value is within this interval, it means that it's surely rounding to 0.432 to 3dp's as required.